All right, welcome back to part 2 of this video. Um, in this part, we are going to cover solving logarithmic equations. Okay, so in the first video, we looked at how to solve exponential equations, and we stopped off right over here using factoring. Okay, so now we are going to look at log equations. Solving logarithmic equations. Okay, so in the first video, when we looked at solving exponentials, we used logs to solve exponentials. And so here, for solving logs, we're going to use exponentials to undo the log. Okay, because remember, exponentials and logarithmics are inverse functions of each other. Okay, so they undo each other. So we use logs to undo the exponential. And here we're going to use exponentials to undo the logs. Okay, so let's go ahead and write some things down. So we're going to use exponentials to solve. And here, because we're solving logs, and log, there is a restriction on the input values. So when we're taking the log of something, we can only take logs of numbers that are greater than 0. Okay, so because of that, we have to check our final solutions. Okay. All right, so let's go ahead and take a look at the simple case. So just like with exponentials, you had a very simple case. It was very intuitive. If the bases match, then the exponents must match. So same here. So let's take a look at a simple case. Suppose that you have to solve this. Log x squared plus 1 equals log 5. Okay, so again, if you don't see a base, then this means common log base 10. Base 10. Okay, so here, I'm going to go ahead and write it down here so I can do work with it. All right, so here we see that, oh, okay, the two bases match. So if the two bases match on the logs, okay, so if these are the same log with bases, then here, these two must be the same. So we can go ahead and say that x squared plus 1 must be equal to 5. And here we can solve. Okay, so here, if I subtract 1 on both sides, x squared equals to 4. And I'm going to take the square root to cancel the square. But remember, when you do that here, you end up with two answers. So we get positive 2 and negative 2. So we get two answers here. And we have to check. And you will probably see, let's see what happens. Okay, so if I check this, if I plug in 2 first, positive 2, then I get log of 2 squared plus 1 equals log of 5. And we're going to check that it does equal the log of 5. Well, we can already see it. 4 plus 1, and that equals log of 5, right? Log of 5 on this side, log of 5 on that side. All right, so it does check. So x equals 2 is an answer. What about negative 2? So negative 2 squared plus 1, does that equal log 5? Okay, and here we get 4, positive 4. And we do see that log of 5 equals log of 5. Okay, so both of these are answers, so I can go ahead and box those two. Okay. All right, let's take a look at this next one. So over here, when you have this single log equals this single log, then the inside must be equivalent to the inside here. So we can say, oh, okay, well, if we have log base 10, then x squared plus 1 must be equal to 5. Okay, so that's if you have a single log here and a single log there. Okay, let's take a look at this one. This next one may not look like that type of problem initially, but let's take a look at it closer. Solve log x squared plus 1, which equals log x minus 2 plus log x plus 3. Okay, so I was saying that, oh, you can use this idea of setting the x squared plus 1 equal to the 5 if you have a single log here and a single log there, right? And when we look at this problem, it's like, okay, well, we don't have a single log over here. But if we use our laws of logarithms to condense this, right? Because when we have a sum, we can rewrite it as a single log of a product, right? So I'm going to go ahead and bring this side down. But over here, I'm going to use my laws to condense this. So I'm going to write it as single log of a product, x minus 2, x plus 3. So now I do have a single log here and a single log here. And so I can set these two equal to each other. X squared plus 1 should be equal to this product over here. Okay, so x squared plus 1 must be equal to x minus 2, x plus 3. X squared plus 1 equals x squared. 3 subtract 2 is 1, x minus 6. Okay. And then here we see that the x words will end up canceling out. So we get 1 equals x minus 6. I'm going to add 6 to both sides. So I get 7 equals to x. Okay. And we're not going to box it just yet. We need to check. All right. So going back to the original problem here, log 7 squared plus 1. We want to know, does that equal log of 7 minus 2 times 7 plus 3? So log of 50 should equal to log of 7 minus 2 is 5, 7 plus 3 is 10. And we get 50 over there as well. Okay, so we do get log 50 on both sides. Okay, so x equals 7 is correct. Okay, so that's these are the simple cases where you have a single log on both sides, then you can just set these equal to each other. You'll see that to solve these, we did not use any exponentials yet, okay? This is a simple case. All right, so let's get into the more complex ones where you do have to use exponentials to undo the log. Okay. So, guidelines for solving. Okay. This is not scrolling for me. I wonder if there shouldn't be a limit. Hold on a second. We might have to I might have to restart this. All right. That's the first time that's ever happened. Okay, so going back to our guidelines. Here, I'll just write guidelines. Hopefully you copy the rest of the other stuff down. Oh, actually, here, let me just write it again. Guidelines for solving log. Okay. All right. So just like with exponentials, we're going to go ahead and isolate the log term. We're going to rewrite this step right here, the second step here. You can look at it two ways. You can think of it as rewriting the log in exponential form. Or you can look at it as raising the base to each side. And that will make more sense. That says base. Let me rewrite that. This second part here will make sense once you see it. To each side. Okay, and then solve. So when you do this second step right here is where this second step right here, this is where you end up canceling the log. Okay, so once you get the log by itself, you're going to go ahead and cancel the log, and you do it by doing this second step here. Once you cancel the log, then you're able to solve for x. And the last step you need to do is check. Okay. All right, so let's take a look at an example. So over here, suppose that you have to solve ln x minus 5 equals 3. Okay, I'm going to go ahead and bring it down here. Okay, so we don't have a single log on this side with a single log on that side, so we can't solve this the way we just did those simple cases. All right, so we do have to isolate the log term. So I'm going to go ahead and add 5 to both sides. And I end up with ln x equals 8. Okay, and so this is where you need to somehow cancel out that log. And remember, exponentials and logs cancel each other out. So here, this is log base e. So I'm going to go ahead and use base e and raise it to each side. That's what I mean on that second step here. Raise the base to each side. Okay, so this is base e. So I'm going to do e to this and e to that. And these will end up canceling. And that's how you cancel out the log. So you get x equals e to the 8th. Okay? And we can check. If I do ln e to the 8th minus 5 equals 3. Over here, these guys cancel. So I get 8 minus 5. That's one of our properties that we learned about. And we do get 3 equals 3. So that works. Okay. All right. Let's take a look at another example. Let's solve log base 2, 25 minus x plus 7 equals 10. Okay, I'm going to go ahead and bring it down here so I have room to do the work. Okay, so here I'm going to go ahead and get the log term by itself. So I have to subtract 7 on both sides. And I get log base 2, 25 minus x equals 3. Okay, so the first problem we did here was base e, log base e. So I use e as my base here, e to this exponent. This is what I had left over. Ln x is here. 3 plus 5 is 8. Okay, over here, it's base 2. Okay, so I'm going to use 2 on both sides. Okay, and so here, these will cancel out, leaving me 25 minus x equals 2 to the third is 8. Okay, and then if I subtract 25, I get negative x equals negative 17. So x equals 17. Okay. Oh, not going to box it just yet. Habit, right? Okay, so log base 2, 25 minus 17 plus 7. Does that equal 10? Okay, so log base 2, that's 8, plus 7 equals 10. This here is 3. 2 to the third is 8, plus 7 equals 10. 10 equals 10. Okay, so it checks. Okay. All right, let's go ahead and take a look at another example. Okay, let's go ahead and solve this one. Solve 4 plus 3 log 2x, which equals 16. Okay, so let me bring it down here. 2x. All right, get the log by itself. So I'm going to subtract 4 on both sides. I get 3 log 2x equals 12. Divide both sides by 3. I get log 2x equals 4. Okay, so this is where I'm at. I got the log by itself. Remember, no base is base 10. This is common log. Okay, so no base is base 10. So I'm going to use base 10 on both sides. And we get 10x equals 10 to the 4th. Okay, so 2x equals 10 to the 4th. So that is 4 zeros there. Divide both sides by 2. And we get x equals 5,000. Okay, and then we're going to go ahead and check this. Okay, 4 plus 3 log 2 times x, so that's 10,000, equals 16. That's what we wanted to know. Okay, so we get 4 plus 3. Log base 10 of that is 4. And then 4 plus 12. And 4 plus 12 does equal 16. 16 equals 16. True. Okay. Okay. And let's take a look at this next one. Log x plus 2 plus log x minus 1 equals 1. Okay. So when we're solving logs, we always like to have as few logs as possible. If we can get it down to a single log, that would be great. Okay, so either a single log on both sides or just a single log on one side. Okay, so over here, we're going to go ahead and we want to combine, we want to condense these here to a single log, and we're going to use our properties to do that. Okay, so over here, we're going to condense this by using our properties. If you have the sum of two logs, then you can condense it to a single log of a product. Okay, so that's what we're going to do. Single log of the product x plus 2, x minus 1. Okay. All right, so now we have our single log, so we can go ahead and this is base 10, so we're going to base 10 on both sides to cancel out the log. And we get x plus 2 times x minus 1 equals 10 to the first is 10. Okay, I'm going to go ahead and multiply this out. So I get x squared. 2 minus 1 is 1x, and then minus 2. Okay, if you're not sure how I got this trinomial, you'll just have to go off to the side and multiply this out on your own. X times x is x squared. X times that is negative x. 2 times that is positive 2x. 2 times that is negative 2. Combine like terms, and you get x squared plus x minus 2. Okay? But I showed you how to do a shortcut on doing this. So that's what I'm using here. All right, subtract 10 on both sides because we have to set this quadratic equal to 0. So x squared plus x minus 12 equals 0. And then I'm going to go ahead and try to factor this. X times x to make x squared. I want negative 12, so the signs have to be opposite. And it looks like 4 and 3 will work. Yep, okay. All right, so x plus 4 equals 0 or x minus 3 equals 0. Subtract 4, x equals negative 4. Oh, I'm not going to box it yet. Add 3, x equals 3. All right, so we have to check both of these. Here, let's go up here. Let's check negative 4. All right. Okay, so log of negative 4 plus 2. Okay, right there, because I get negative 4 plus 2, this is not going to work. Okay, because we don't want to take the log of a negative number. Okay, so that's not going to work. All right, let's try x equals 3. So that will give me 3 plus 2 plus log of 3 minus 1. Does that equal 1? Okay, so that's log 5 plus log 2. Does that equal 1? And then we have log, I'll rewrite this as a single log of 5 times 2. And then log of 10. And yes, 10 to the first. Right here, this is, remember, common log is base 10. So this equals 1. So yes, x equals 3 works, but this one does not. Okay. All right, so that is it with solving log equations. If you want to see some applications done, then watch the third video where I work out one problem on compound interest, and then I have you try one. Okay, see you next time.